All right, folks. So here I am recording for this new upcoming week. I want to give you guys first a heads up. I've actually already done it. I'm re-recording this because this was a huge project and I ended up redoing stuff and this has gone crazy. So I'm re-recording this beginning. What did I make? I wanted to make an alarm. I've been wanting to do this forever. So this alarm, I want an alarm for my front yard, that is. And they already sell stuff like this already where it senses somebody walking on your house and then like a floodlight turns on and it shines down on your yard. And they kind of work. I mean, if you're at 3:30 in the morning looking around to look into a car and a big floodlight shines on you, you might move because all the attention's on you and you don't want anybody to like notice you. So they kind of work. I'm going to do it myself, so I'm going to make one. And instead of shining a light, I could do that, but I'm going to instead maybe make it a sound, right? And I could sense somebody in my yard, then play a sound like a like an alarm sound. But instead, I'm going to do something else. I'm going to hire a voice actor to say something. So I just thought that was cool. So first off, how am I going to send somebody? I'm going to send somebody using a PIR sensor, a passive infrared sensor. So if I go here and I just show you one, you'll probably seen one before. I'm going to type in passive infrared sensor. And this is what they look like right here. You've probably seen them images right here. This is what it's going to look like for me. Sometimes in houses in the corners and walls, you see them. They look like that right there. But so that's what I'm going to use. I'm going to use a Raspberry Pi, which I'll talk about in a minute, to control all of this. And I need somebody's voice. So what I did is originally is I searched the internet. I kind of just looked, voice actor search and found all kinds of stuff here. Then I came upon this voice 123 thing, and I searched all kinds of robotic voices, everything, and I looked at British's actually with one T. But anyway, I ended up listening to different ones, and I settled on this one right here.
Ibiza, 24/7 Pachar Ibiza fragrances. Live my Ibiza.
I thought she had the most like kind of robotic sounding professional voice. But she ended up saying she couldn't do it because even though I only asked her to do one single line, she was doing audiobooks and stuff right now, so she was too busy or something. So I kept searching and searching for something like semi-cheap, and so I ended up coming across this on Reddit. There's something called Voice Actor Listening and Recruiting. So it's called Our Voice Work, And what it is people that want, maybe some of them are aspiring, they want to do work, they're willing to do it, pretty cheap, and some of them probably even do it for free. I've offered to pay somebody, though, to do it. The person I found was this person. That was just the first person who replied, and she's done like I think she was on a Doctor Who episode where her voice is on the background as an alarm system or something, so it kind of worked good. She sent me all kinds of samples, and here's one.
Why does a duck have tail feathers? To cover its butt quack. Sorry, I don't know how to help you with that. Here are other things you can try.
So this is her samples, and she gave me a bunch of other samples too. So I ended up using her voice. So that's what I ended up doing, and I set it all up. And first, I'm gonna in my intro, I'm gonna show you what the Raspberry Pi is. That's the computer that I'm gonna use to control all of this. The little tiny thing. Then I'm gonna talk a little bit about passive infrared sensors. And then I will put together on my desk right here where I'm sitting a little tiny setup just to test it, see if it's working with some headphones and stuff, no speakers or anything like that. And I'm going to test to see if it's working and stuff. Then finally, I will test it outside and kind of readjust the sensor and stuff and get it all right and test it out and walk up to my driveway and maybe go up to a car and see if it works. Okay, so get ready and hope you like this video, guys. So this is the Raspberry Pi that I'll be using for the project. I'm going to code this thing, or I'm going to add some code into it. Let's talk about it. It's a little mini computer. It's literally a computer. It has USB ports, 4 of them. It has an internet port, but you don't need it because it has a built-in Wi-Fi chip. On this side, you have to power it, right, with a battery source or some type of energy. It's got a micro USB. So you need to plug in a micro USB. Same thing you would use to charge a phone or something like that. Though, you need like 1 or 2 amps. It's got to be a good strong one. It can't be a little cheapy one. Then it's got an HDMI out, so you can literally put it to a screen, a computer screen, with sound and everything. it also has an analog speaker output, like for an old audio jack. You don't need it because it does have sound coming out of here, but if you needed separate speakers, you can do that there. It also has like two of these things right here, these little things where you put ribbon cables and they go to cameras, or the other one's a screen. So one's for a camera, one's for a screen, a display of some sort. Though you could just hook it to a regular TV monitor, you know. Anyway, it also has all those. That's called, those pins right here are called headers. And it's like 40 pins there, and they're most of them. Some of them are positive, some are negative power. There's different stuff there, but the majority of them are GPIOs, general purpose input outputs. That means they can be inputs, you send signals in, or they can send signals out, like, hey, you need to turn on, you need to turn off, or hey, something turned on, hey, something turned off, you know, which, in other words, somebody pushed a button or something like that. So it's sending signals saying something's happened, or it's sending signals out telling things to do things. I'll be using those GPIOs for the sensor. And let's take a look at the code real quick, okay? Okay, so if I want to start coding, I'm on my regular computer. I'm using this recording software. It has a picture of me, and it has my screen. But I need to go into that Raspberry Pi. Raspberry Pi is booted up. I put in all the software. It's running right now. It actually is connected to a monitor right now too, but you can't see it obviously. But actually, to let you know, it does not need to be connected to a monitor. Just like a regular computer. A computer runs without a monitor. But if you want to see stuff, you need the monitor. So it doesn't even need the monitor right now, but I can still see the screen without a monitor, and I'll show you how. I'm going to use something called VNC Viewer. So I'm going to go VNC, and there's my VNC Viewer. And it's hooked up to this IP address on my network. I'm going to double click on it, and look at that, I'm in. This is the Raspberry Pi monitor. This is their screen right here. It's the screen of that little tiny computer. So if you look, I want to start coding, so I'm going to go here to this little Pi right here, and I'm going to go to Programming, I think it's the Python IDE, I guess. This is new to me. This is a newer version, by the way. I wrote the code somewhere else already. Let's see if I can find it. I'm going to go to Load. Let's see if I can find it. And it should be in my documents. Yes, Alarm. And I think it's Alarm 2 was the one that looked like it would work. Oh, look at that. Actually, I do like this. It actually looks a little bit more professional, I guess. So, that's not much code here. It's not completely done. But what happens is that first you have to import things. So there's tons of things that this thing can do, this software. But to make the program lighter, you only import things you're going to use. There's millions of things. Okay? So I'm importing this thing right here, import time. I've done that before, and that's because I'm going to use a sleep thing. In your Vex stuff, that was called what was that called? Wait, right? So you'd use wait command, wait 3 seconds, and it waits before it does the next line of code. If you're using if you're using an Arduino, and so when you're a junior, you're going to use an Arduino, and the code would be delay, D-E-L-A-Y, and then you in parentheses you put how long you want it to wait. That's in milliseconds though. This particular one is sleep, and so to use the command I have to say time. That's the library I'm using, and there's a bunch of different codes in this time library. I'm using the sleep one, so I say time.sleep, and then I have to put in parentheses how many seconds. That's just the way you got to do this particular Python code. So I imported that because I'm going to use it, and then import Pygame. Honestly, I've seen that before. I've never used it. I just looked up on YouTube how to get Python code to play a sound. And actually I saw a bunch of different tutorials. One of them said use Pygame, because Python actually has a game library, like if you want to build your own game and code one. It's got I heard it's a really decent one. So they're like, this guy's like, yeah, you can just use Pygame to run your sound, you know, because games have sound, right? So that was interesting. So I thought, okay, I'll follow that and try it out. I tried 2 different methods. That's why you saw 2 alarms when I was looking for one. I used alarm 2, and this one seemed to work first. So I'm just sticking with this one right here. So I need some ability, so I'm importing that. Then I want to use the inputs and outputs, right? So to do that, I need to import a library of things. So I put import RPI Raspberry Pi GPIO as GPIO. That way when I use GPIO, I just have to call it that. I don't have to call it the long name. Then first thing you're supposed to do when you're going to use a GPIO is you have to set the mode to a certain thing, BCM. This mode is, it's kind of hard to explain, but if you know those little, the pins that I showed you guys, these little pins up here, all those, that header with 40 pins, there's two different ways to look at it, just by really easy numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, and then the next row is, 21 through 40. And the other way is the way the chip kind of sets it. So, there's just two different methods. So when I say 23, it's asking, it needs to know what method am I using. Okay, so that's all. So when I'm saying pin number 23, and it's asking me what number 23, like just by counting regular like numbers, or by what the chip knows what it's sending signals out of. It's kind of weird. So you just have to do that. I don't want to get into that, but next thing you do is you have to set it up, and you have to say what pin. 23, I'm going to use number 23, and is it going to be an in or out? I'm saying it's an in. So it's going to be listening to a signal from my little sensor that's going to sense if somebody's on my lawn. If somebody's on my lawn, my sensor is going to send the signal to this Pi. Then you have to initialize the Pi game. I didn't know that, but the guy told me on the YouTube video. You have to initialize it, means start it all up. And then I created this little variable. It just says I'm creating a variable called alarm. This is how you create one in Python. So I put alarm is equal to, and then I put pygame.mixer sound, and I put the name of my sound file right here. I had no idea how to do that, but the YouTube guy said that's how you do it. And, so this is how you refer to a sound. And then if you want to play a sound, you have to put the name of the sound, like right here. You know how I named it alarm right here, right? I put alarm. Now, from my understanding, how variables work is I could have just put all of that and then put .play. But of course, if you're going to do this over and over again, it's easier just to call it alarm, and then you just put alarm.play and put the two parentheses. That's it. Then I'm saying sleep for 5 seconds and then to repeat. I just did that for purely testing to see if this thing worked. And it worked, because I didn't have my sensor hooked up and GPIOs. I knew I was going to, so I set them up to do it, but I just didn't have time. So I said, let me just see if it plays it, waits 5 seconds, then plays it again. And it does this over and over again in this while true loop. Isn't Python cool? Look at no brackets needed, Like if this was the other code, we would need to put a bracket here and a bracket here to say end it right here. However, it, oops, let me Control Z. It figures that out by how you, tab. You see that space right here? This tabbing becomes super important because it doesn't use brackets. So while true, do what? Just this stuff? Yeah. So when I write no more code right here, it knows to only loop this stuff in that while true loop, because this is tabbed over, but this code right here is not. So this new code right here, that's not going to loop because of this tab system. So the tabbing is super important. Tabbing over and moving that little spaces, that's super important, but you don't need brackets. So, to each his own. But what I'm going to do is I'm going to say if, and I'm going to say if, then I'm going to put GPIO pin. I'm going to have to look up the code for this, but if GPIO pin 23, I'm just making this up, is equal to 1, so that means it turns on, then do this code, and then otherwise just don't play it. So if it senses that my thing has gone to 1, it's going to play the sound, and otherwise it won't. So that's how it's going to work. We'll try it out and let's see, okay?
So here it is hooked up. That wire right here, the first one on the left, that's positive 3 volts, 3.3 volts. The yellow one is ground. And the blue one right here, that's pin 23, or what's called pin 23, GPIO 23, I should say. And they hook up to a breadboard, which then hooks up to my PIR sensor. And that PIR sensor turns red when it senses motion. I'm going to give you an example right here. So I'm going to put my hand, see, I just moved my hand near it and it turned sensor. Now, I want you guys to be able to hear it. And I hooked up a headphones right now. My speakers, I ordered them. They're not in yet. So let me see if I can put this headphone like right on the mic on this. And let's move it in. And it just keeps playing it over and over again. And then I'm going to move away. and it completely stops because it's not sensing anything. But if I swing my seat around just a little bit, whoops, well now it's really gonna do it. It fell off the table. But it works. Okay, so going on to the next stage, getting it all set up. So there it is, guys, right now. I did do some wiring right there. That's the Raspberry Pi. The PIR sensor, I'm just trying to fix something with some dumb aluminum foil right now. I can always fix that later. So that's it. It's pretty small actually, you know. It's pretty small. So let's try it out real quick. All right, here I go. I'm gonna walk up to my house and test the alarm out. Now, I would like it, to be honest, right about the time I'm about to touch these cars, I'd rather it go off now. I can't make any adjustments on this particular PIR sensor. This passive infrared sensor has no settings really. It has like a little jumper, long range, short range, but there's other ones that you can adjust like a lot better. So I think I'll get a different one later, but let's just hear it out and see if it works.
Warning. Perimeter breach detected.
It worked. It's not ridiculously loud, but I think I want it like that when I just got the text message right now on my phone that it went off. See? The text message thing works.
Warning. Perimeter breach detected.
I have it set for every 10 seconds, so it'll say it every 10 seconds until somebody moves out of the way. So there you go. There it is. It works, guys. Is it perfect? No, but it's pretty cool. Hope you guys liked it. Bye.